All right, hey again, students. So I'm expecting you've filled out these tables, you've graphed those points, you have some graphs for sine and cosine, you probably feel okay about them. Tangent maybe got a little funky, and that's fine. So if you're done with that first, let's go ahead and check out what you should see. Sine should look something like this. I filled in the table, you probably have the same values. If not, maybe let's chat. And then, yeah, we get a sine function. You can see the curve like here, it's just slightly curving downwards. And so it makes sense that we should have symmetry. So I spaced these values out more, but you kind of follow the same shape or pattern as it goes. And that is the way the sine function works. Cosine, same type of idea. It's interesting to think of, why is this thing going like up and then coming back down and then down and back up? Like, why is that going to repeat like that forever? It's strange. We've also only looked at sine and cosine in 90-degree triangles, which means we, up until this point, have only seen like this part of the curve, and we've only seen this part of the curve, which is interesting. Now we see like, well, sine can extend beyond that. These are conversations we're going to have very soon. And for tangent, we get these values in here, and the asymptotes on the end mean you need to approach them. And so we get some function that looks something like this. Now, my graphs are not perfect, so let's check out what perfect graphs look like. And I want to note that the x-axis is going to change significantly here. And it's for a specific reason that you don't need to know for the IGCSE. If you're interested, we can talk about it. It's really the difference between degrees and radians. Oh, and I should have noticed this should be a 90, and on your worksheet it was an 80. Sorry about that. Okay, let's look at what those graphs, I don't have it here, there it is. Cool, so sine of x looks like this, and we've seen this, like the high point right there is at 90 degrees. We've seen this is at 180. The low point here is at 270. And then we're back to 0. If we started at 0, we're back to 0 at 360, which makes sense. We've gone all the way around the circle, we're back to 0. So it is a little bit interesting that we've thought about sine as being a triangles thing, and now we see circles things coming up, like 360 degrees. That is interesting. Again, we'll talk about it soon. Cosine, we see similar types of things. At 0, it's at 1, at 90, it's at 0, at 180, it's at the bottom, and then it goes back up to the top. And we see the sine and cosine curves are almost identical. In fact, they are identical, except they're shifted over. So I could actually shift the cosine function over, and it would match exactly with that sine function. And it should make sense. Just think like, if I could translate and take this point and shift it over until that point is here, then these curves would match up. So, okay, good. Last one is tangent, and tangent's weird. This is what it looks like. We saw a bit of the negative going back to negative 90 degrees, but you see that same shape repeats forever, and we have all of these vertical asymptotes, like every 180 degrees, we get another vertical asymptote in here. So good, cool. Those are some of the things that I expected you to see going through that. Now let's talk about the way we're going to use these ideas. So I want to look at the other assignment for today. Great. Let's talk through a couple of these. We've got cosine of 120. So I guess I'll try to color code. Cosine of 120. And we want to express each of the following in terms of the same trig ratio. So we want the same trig ratio. The cosine of 120 has to be equal, but a different angle, another angle between 0 and 180. So we basically want to find cosine of 120 is equal to cosine of what? And this angle here has to be between 0, I'll say 0 is less than angle is less than 180. So we have to be between 0 and 180. I guess they didn't say we couldn't equal them, so I guess I'll put the equals on there. Let's look at what we think. Cosine of 120, and we want it to be equal to some other cosine. Well, our cosine function is here, and I think 120 degrees, 90, 135, so 120 is here. And I get this value down here. So my cosine value is that value right there. And if I follow it across, I'd see there's another cosine value over here I'm a little interested. This other cosine value is not between 0 and 180. And I think they said we had to be between 0 and 180. So between 0 and 180, maybe there isn't one. When I look out here, that's this value. So if that's 225 and this is 270, then that's plus 15. So 225, 35, 240. So I would come back here and say, this could be 240. But if I have to be between 0 and 180, when I look here, we need this same cosine value between 0 and 180. I don't see any. So I actually think for A, you could put no solution, and I would be fine with that. If you put 240 degrees, I think that is a great answer. It technically doesn't match the instructions, so that's interesting. Let's look at one or two more. Let's say sine of 35. Okay, if we want sine of 35 is equal to sine of some other angle, and we want to be between 0 and 180. Let's go back here. Okay, now we're looking at sine. I wanted sine of, is it 35? 35 degrees. So here's 45, meaning this is 30. So 35 is like in here, 35. And that hits the curve like there. So then I would think I want that same trig ratio. And this one does have an answer between 0 and 180. When I go over here, I see there's an answer there. And so it looks like this was 5 degrees more, so this is probably 5 degrees more. That's going to be 140 degrees. So sine of 35 equals sine of 140. And that's interesting. You can go ahead and test them. I mean, I could test them here. Let's see. Let's see, 35 sine, I get 0.5736, and 140 sine. Ooh, we're very close. It means we made a mistake. What's the mistake? It's just after 30 degrees, which 30 degrees is like 2 boxes out from 0. So 2 boxes out from 0, it's going to be 145 instead. That's my mistake. So let me change this, and then let's test it. Honestly, if you said 140 instead of 145, I wouldn't really care. I care about the strategies and the way you're thinking right now. 145 trig sine 0.53 or 5736, exactly what I had. They're both going to be over here. 5736, 5736, those are our two, and they are equal, so that's good. Sine of 35 is equal to sine of 145. Let's do one more just because it feels a little weirder to me. The last one I want to do here is cosine of negative cosine of 140. So negative cosine, I wanted to change color. Negative cosine 140. I'm going to look at it like this. First I'll find cosine of 140, then I'll do the negative second. So, okay, let's go here. We've got cosine of 140 is there. So cosine of 140 is down here. That's like a little less than 0.8, so I think, or negative 0.8. So cosine of 140 is approximately equal to negative 0.8. So if I have negative cosine, it becomes positive 0.8. So now I want something that's in the ballpark of positive 0.8. And it's going to be somewhere back here. So I see this value is like that value, kind of symmetrical. And then I kind of look at the space here to make sure it matches up. So from the top of the curve, it's like 3 boxes and then a little bit back. So from the top of the curve, it's going to be like 3 boxes and then a little bit back. It's going to be in here somewhere. And it was 135 plus 5. So here it's going to be 45 minus 5. This is going to be at 40 degrees. So you can use that symmetry. So this should be equal to cosine of 40 degrees. And let's go ahead and test it. So bring out my trusty calculator that I closed. Okay, 140 trig cosine negative. So 0.766, and then 40 cosine 0.766. They're exactly identical. So nice. So that's the whole idea in the first ones. So now the second ones I actually think get slightly easier. So let's check out one or two of them. Okay, sine of theta equals 1/2. Well, this is because our graph is in decimals. Sine of theta is 0.5. And we want to give all solutions between 0 and 360. Okay, so sine is 0.5. So I'm going to go back to this sine curve. I'm going to say we want 0.5 is like there. We want all the solutions possible. Well, I see a solution back here, and I see another solution out here. And so it looks like it should be like maybe 25 or 30 degrees, and 135 plus 15, 140. So let's say 25 to 30 degrees. I think it's going to be 30 degrees. And then 135, what was I trying to think? Oh, if this is 2 boxes in from 0, this is 2 boxes in from 0. So 35, 45, 150. So this is going to be like 145 or 150 degrees. And then I think it's going to be 150. And then we can just test it. We know we want it to be 0.5. Did I close my calculator again? I did. 30 degrees, sine 0.5. 150 degrees, sine 0.5. So when I come back to this, that means the solution to this equation is theta equals 30 degrees or 150 degrees. And so that's the whole idea with these. I think that's all I want to say for right now. If you have questions, I'd love to talk about them. And I would expect you might have questions, especially about like tangent here is a little strange. So this might be something we continue talking about. Let's see how far you get. And if you have questions, call out to me. If we get to these next ones, they start to get even weirder. So here's the idea here. We want, well, these actually, when I look at these aren't as weird. Well, let's just think about what this has to be, right? Sine of some angle is equal to sine of 35. And we want the smallest positive value. So then I would just go back here and say, what was it? Sine of 135 is equal to the sine of some other value. So I'm just going to say sine of 135, I was using purple. Sine of 135 is here. And if I follow that across, it's also here. So the smallest angle is 45. So really, these ones are very similar to the last ones. So this would just be 45 degrees. Yeah, but some of these start to get weird, and you might have to think about them. We also don't super need them for the IGCSE, but they're worth talking about. So if you're struggling, great, let's talk about them. The main thing then that I would want to also convey, especially when we look at these last ones, but in any of them really, is that we can use any algebraic ideas. So for example, in this case, I could square root both sides and get the sine of x equals the square root of 1/4. And then I can square root that, get a decimal, and solve it. Or in this one, maybe I don't like the cosine of x, so I would just say cosine x equals some other variable. I'll just choose y. So then this is 8y squared minus 10y plus 3 equals 0. Well, this is easy because that's just a quadratic. And then after you've solved, we just have to know those solutions are for cosine of x, and we have one added step to solve. So go for it, try these out, let me know how they go, and I'd love to chat about them. Best of luck, and let's talk soon.